Okay, welcome to this week's session. Today we're going to discuss the basic concepts of discrete probabilities. And the following week, which is on Monday, we then can discuss the other properties of discrete probabilities, including the binomial and the Poisson. And we'll see if we can split those ones into two sessions. Okay, so by the end of the session today, you should learn what are the basic properties of a discrete distribution or a discrete probability distribution, how to calculate some of the properties like your mean, your variance, and your standard deviation, and how to find the probability of a discrete variable. Then we'll do some lot of other activities at the end. So a discrete probability distribution comes from a discrete variable. So it's a process from where you collect data from a discrete variable. And remember, discrete variables are those variables that they can be counted, are your categorical variables that can be counted. And this probability distribution is mutually exclusive listing of all possible outcomes from that variable, and the probability of occurrence will be associated with the outcome of that variable. We dealt with outcomes and events when we dealt with probabilities, so I'm going to assume that by now you know what an outcome is. Outcomes are those data that comes from a process or that comes from an event. So with discrete probabilities as well, we're going to have your outcome, but within your outcomes, and within those outcomes, we can calculate then the probabilities from them. So for example, like if we're looking at this table, the number of assessments, if they follow a discrete distribution, where there can be a module where there is no assessment, there is only one assessment, there are two assessments, there are three assessments, four assessments, and five assessments from that module. And let's say this is 1610, right? So in 1610, how many assessments or tests that you are writing, assignments that you are writing? You've got 5 assignments, so therefore it means the count for that module would be 5. So there will be other modules where they only give them 4 assignments. There will be other modules where they get only 2 assignments or no assignment at all. You just go and write the exam or submit a portfolio of evidence. So those kind of outcomes, then we take all of them and we count them, how many in each, which means there will be some frequencies which you don't see on here. The frequencies of each occurrence or of each outcome will be counted, and with those frequencies, then we calculate probabilities. And these are the probabilities. So with those events, we calculate then the probabilities. And then these are the probabilities. The sum of all these probabilities should always be equals to 1. This is the same information that you have learned from the basic probability, that the sum of all probabilities should always be equals to 1. So this is a discrete probability distribution table that you also need to familiarize yourself with. When you get this kind of a table in the assignment or in the exam, you need to recognize that this is a discrete probability distribution table, and therefore from here I can be able to answer any other question that I need to be able to answer from that and the questions or activities that are related to this. Okay, so if we want to calculate one of the measures of central location for the discrete probability, which is the mean, or what we call the expected value, we use the formula. The mean of a discrete probability is given by the sum of the observed value multiplied by, or the observed outcome multiplied by its corresponding probability. So remember our table, I just transposed it and wrote it this way. where we have our outcome and our probability. So we take the sum of all the values when multiplying each value with its own corresponding probability. So it means 0 times 0.35 will give us 0. 1 times 0.25 will give us 0.25. And we do the same for all of them. And when we're done, we just add, because the summation means adding up. So we add 0, 0.25, 0.4, 0.3, 0.2, and 0.25, and they give us the mean of 1.40. If we need to calculate the standard deviation, oh, sorry, not the standard deviation as yet. Let's look at an example from this question that we have. Suppose the distribution of the number of people per household follows this distribution. The first thing what you need to notice with this question is there are missing, or there is a missing probability. So knowing that the sum of all probabilities is equals to 0, therefore it means we can find the value of x by adding all these values and subtracting them from 1. So that will be 1 minus into bracket 0.25, okay, so let's do it this way. 0.25 plus 0.33 plus 1, 0. Plus 0.17 plus 0.15 equals 0.9. So therefore it means our x will be equals to 1 minus 0.9, and therefore it is equals to 0.1. And that's how you will find the value of x. To calculate the value of the expected value or the mean, we then going to say 1 multiplied by 0.25 is 0.25. So we're going to say x times the corresponding probability, and that will give us 0.25, and this will be 0.66, and 3 times 0. Is 0.51, and 4 times 0.15 is 0.6, and 0.1 times 5, it will be 0.5. Then we can just add them together. 0.25 plus 0.66 plus 0.51 plus 0.6 plus 0.5, and that gives us 0.25 plus 0.66 plus 0.51 plus 0.6 plus 0.5 equals, and that gives us the expected mean of 2.52. That is our expected. Okay. So to calculate other properties, we can calculate the variance by using the formula, the sum of your outcome minus the expected mean. We calculated the expected mean squared multiplied by its corresponding probability. To calculate the standard deviation, we take the square root of the variance, which is the square root of the sum of your x observation minus the expected value squared multiplied by its corresponding probability. How do we do that? Using our first example of assessment, where we have our outcome and their corresponding probabilities. Now, because this is a complex formula, let's say we need to calculate the standard deviation. Because of its complexity, I like to use a table format type of things so that then I can also see clearly where I am going when I answer the question. And especially because there are so many values to work around. So the first thing that I do, I break the equation into two parts. The first part is to calculate the first part within the summation, which is your observation minus your expected mean squared. So what you do is you say remember our expected mean, we calculated it and we found that it was 2, sorry, this one is different. We found that it was 1,4. 1,4. So we calculated it was 1,40 when we did the calculation. So because we found that it was 1,4, so we say 0 minus 1,4 and we get 0. We get minus 1,4 and then you square that answer and you get the answer of 1,96. And you do the same. 1 minus 1,4, which is 0,4 minus 0,4. And square the answer that gives you 0,16. And you continue with the rest of them. We would have done this part. Now we need to take that part, multiply it with its corresponding probability, and you just take that value and multiply 1,96 multiplied by 0,35, and you get the answer of 0,68. And you do for all the values, and then you add all these values because we are saying the sum of your x minus your mean squared times its corresponding probability. So it means we're adding all these answers and we get the standard deviation of 1,40283. If we're only working out the variance, which is the summation, we get 2,04. And when we take the square root, we will get the answer of 1,428. Let's look at this example. So we know that we calculated this one was 0,1 and we know our expected mean, we calculated it was, let me write it right here at the top. Our expected mean is 2,52. Now we're going to apply the same formula. So it's x minus the expected squared times its corresponding probability. I'm going to do everything that is underneath because I'm going to save time right now. So we're going to do everything underneath the square root. So that will be 1 minus 2.52, and then I'm going to say equal. I get the answer, and then I put the square. I get 2.3, and I multiply that answer that I got with 0.25, which gives me an answer of 0,5776. So what did I do? I said x minus the expected mean squared times its corresponding probability. That's what I did, and I'm going to do for all of them. So it's 2 minus 252 and answer equals squared, multiply that with 0.33. And I get to, please also do the calculation on your side so that we are able to check our answers. I might be making mistakes. 0.89. And when you write your answers, write all the digits. 232. I'm gonna write them under there. And then we go to the next one. The next one is 3. It's 3 minus 2.52. And equals, square the answer, multiply by its corresponding probability of 0,17, which is 0,0391668. Then go to the next one. 4 minus 2.52 equals square the answer multiply by 0.515. And the answer here is 0,32856. And the last one is 5 minus 2.52 equals square the answer multiply by 0.1, which is equals to 6.25. Do you all get the same answer as me? If you don't get the same answer as me, you must let me know, and so we can recalculate and double check the answers. Okay, so now we're going to use the summation. Summation means adding all of them up. So it's 0,5776 plus 0.089232 plus 0.039168 plus 0.3285 plus 6.25. And the answer I get is the square root of everything underneath the square root gives me 7.28456, and that is your variance, and this is your variance. So we calculated the variance, it's 2845. And then we're going to take the square root of the answer equals, and then we take the square root of the answer, and we get the standard deviation of 2,69899, which we can estimate to 2,7 if we want to leave it at 2 decimals, or 2,70 if we want to leave it at 2 decimals, or 2,699 if we want to leave it at 3 decimals. Okay, that's how you will calculate the standard deviation. The long calculation, you just need to practice. Okay, so when we find probabilities, then we are going to be using signs, your symbol, your mathematical symbol, to answer the question. So from the probability distribution that we have, we are going to use the symbols to answer questions like, what is the probability that of having 4 assessments? You need to be able to answer that question by knowing that what equals to 4 means in terms of words or in terms of the sign. You also need to be aware of, sometimes in the questions, they will phrase them in a word phrasing or in a wording, like using normal words than using a symbol. You need to be able to take the words and convert them into a mathematical symbol. Sometimes they provide you with clear, simple mathematical language, which means it's less than, equal, greater than. Those are easy to understand and know and attach a mathematical sign to. But when it comes to phrases, the words or the actual sentence or communication words, like exactly. You need to know that exactly means is equals to. It means in terms of the symbol, it's the equal sign symbol. You need to know when they say below or fewer than, they mean it's less than. When they say it's more than, above, it means it is greater than. You need to know all of this so that you know how to answer the questions. Now, the other interesting ones are the between. You need to know that when they say in the sentence that it is between, generally, between will mean greater than or equal, but sometimes they will tell you that inclusive or exclusive so that it makes it easier for you to understand which sign to use. If they use inclusive, they will put an equality sign to it. And if they do exclusive, they will remove the equal sign. So depending, you also on the mathematical sign side of things, if one has an equal sign, equality sign to it, or less than or equal, and the other one is just the less than, you need to know how to interpret those words. Okay, so let's do some random exercise or activity based on this. Let's say we want to find the probability that at least it's equals to 2. The probability that the outcome is at least equals to 2 is just straightforward. It's exactly, it is at that point will just be equals to 0.2. Let's say they want to say it is at least 2. So the probability that a student will write at least 2 will mean greater than or less than. At least it's greater than or equal, greater than or equal to 2. Or we can also say no less than. So that will mean that we're going to calculate all the values from 2 up to the entire table, where the table ends. So we're going to add 0.2 plus 0.10 plus 0.05 plus 0.05. And that will give us 0.40. Am I right? 3, 4, yes, 0.40. And what if they say it is between 1 and 4 exclusive? So between, X lies between 1 and 4. We always use the smaller one first and then the bigger one last. So if they say exclusive, so therefore it means it will be less than for both sides. And what does that mean? It means it says exclusive of 1. So here is 1 and here is 4, but it does not include 1 and 4. So then it's only those two values. So it will be 0.20 plus 0.10. And that will be 0.30. What if it's the same thing, but they give it to you in a mathematical format and they say the probability that X lies between 1 and 4. But here, X is 1 is less than X and X is less than or equals to 4. What does that mean? So looking at the sign, because the first one says exclusive, so we start at 1, but it does not include 1, and it ends at 4. You always have to highlight all those values, the between them, so that you are aware where you need to stop. So looking at this, it does not include, it includes, so it means it's all these values here. It's 2, 3, and 4, so that will be equals to 0.20 plus 0.10 plus 0.05, which is equals to 0.335. That's how you will find the probabilities. Okay, so when we do activities, you must always also remember this. Okay, so I had this exercise. For the next one, I'm going to exclude doing this exercise. You can take a screenshot of it and you can do it on your own, and we will do more exercise or more activities just now. Okay, so let's look at the activities for today that you need to do yourself. Okay. Africa Check knows that around election time, the number of daily fake news posts about politicians follows the following discrete probability distribution. They give us the X value and its corresponding probabilities, and they've got a question mark at point number 4. Let X be the number of daily fake news. Which one of the following statement is incorrect? So now, the first step that you need to do is calculate the value of a question mark and then answer the questions as they say. Which one of the following statement is incorrect? Number 1, it says the sum of all probabilities is equals to 1. Number 2, it says the probability that X is equals to 4. Number 3, the probability that X is less than or equals to 4. Number 4, the probability that X is greater than or equals to 4. And number 5 says none of the above. So we're going to do this together. So step by step, I'm going to walk through the steps with you. So the first thing, let's calculate the value of a question mark and let me know what is the answer to that. What is the answer for 4? You can also write in the chat if you have the answer. Anyone?
0.7?
Hmm?
Isn't it 0.7?
0.7. If it will be 0.7, then if I add these two numbers, this and this and this, it will be more than 1. So what will be the answer for 4? The question mark, what will be that probability there? Take a complement of that answer you just gave me. You added all these values. If you add them, you get 0.7, right?
Yes.
So then what is the answer for 4?
And this is at 0.3.
Answer will be 0.3 because it will be 1 minus 0.7, which is equals to 0.3. That will be the complement. So 4 is a complement of the rest of them. Remember, from basic probability, we dealt with that. Okay, so now, since we know that, let's answer the question. Number 1, the sum of all probabilities is equals to? If you add all of these probabilities, what did they give you?
Just hold on.
If you add 0.7 plus 0.3, what do you get?
1.
So the sum of all probabilities is equals to 1. That's correct, but we're not looking for the correct answer. We're looking for the incorrect answer. Number 2, what is the probability of x equals to 4? What is the probability at the question mark?
Yes, Lizzie, hold on. We're working it. My older brother.
What is the probability that x is equals to 4? You just calculated it. That should be easy and
0.3.
straightforward. It's 0.3. That's what you just calculated there, right there. It's the probability that x is equals to 4 is this question mark, which is 0.3. Therefore, this is the incorrect answer. What is the probability that x is less than or equals to 4? Which means you're going to count from here and add all of them because it's less than or equals to. So what is that probability? If you add all of the values.
0.7.
Remember, it is less than or equal. So it means it includes that number, right?
Oh.
So the probability that x is less than or equals to 4 is the same as the probability of 0 plus 1 plus 2 plus x is equals to 0 plus the probability of x is equals to 1 plus the probability of x is equals to 2 plus the probability of x is equals to 3 plus the probability of x is equals to 4. You add all of them together. And that will be equals to that plus that plus that plus this plus this gives you 1. We did it in option number 1 because we said the sum of all probabilities is equals to 1. What is the probability that x is greater than or equals to 4? So what are they saying? What is the probability that it includes 4 and it's bigger than 4? There are no other probabilities after that. So all those probabilities are eventually going to be equals to 0. But what is the probability of x greater than or equals to 4? Equals. If we had 5, 6, 7, 8, 9, 10, then it would have been 4, 5, 6, 7, 8, 9, 10. But now we only have 4. What is the probability of x is greater than or equals to 4? Is the same as the probability of x is equals to 4 because that is from here, this point, including that point because there is an equal sign. It means we include this probability at that point and the rest of them, but because the rest don't exist. So this answer is the same as the probability that x is equals to 4, which is equals to, we answered it there in option 2, and we said it is equals to 0.3. Do not get confused. Remember the signs. Okay, let's do more exercises so that then you can understand how to work with the sign. This one asks you to calculate the expected value. So let's see if we can calculate the expected value. Remember the expected value, which is the mean. It's given by the sum of the x observation times its corresponding probability. So it means you're going to take 0 multiplied by 0.1, add to 1 multiplied by 0.15, add, do that. You're going to say 0 multiplied by 0.1 plus 1 multiplied by 0.15 plus 2 multiplied by 0.2 plus 3 multiplied by 0.25 plus 4 multiplied by 0.3. We already calculated this and we said it's 0.3. Zero times 0.1 is 0. 1 times 0.15 is 0.15. 2 times 0.4, 0.2 is 0.4. 3 times it's 0.75. And 4 times 0.3, it's 1.2. Add them together. What is the answer? I've made it easy for you.
$2.5.
The answer is 2.5, which is option 3. Let's see if we can answer this question. A speech therapist knows that the number of children that consult with her on any given day is given by the following discrete probability distribution. Let X be the number of children consulting with a speech therapy on any given day, and the probability associated with that. So we have the table. We know if it's got X and the corresponding probability, this is a discrete probability. Which one of the following statement is incorrect? So we need to validate each one of them and find the incorrect statement. We're going to work this together, one question by question. So you'll give me the answer, number 1. And you are also going to tell me the sign, right? Because they're giving it to us in a word phrases. Let's go back to the word phrases. Take a picture so that you can also always remember. So I'm bringing it back so that you can remember the word phrases and the sign. You will need to remember all this. So let's go and answer our question. I hope you already took a picture or you wrote some of them down. Question number 1, or option number 1. The probability that the speech therapist will consult with at least one child is. How do we write this in a statistical formula manner? The probability, you will tell me yes or no, right? Will it be X is equals to 1? Is it how we write it? Or is it the probability that X is less than or equals to 1? We write it as the probability of X is greater than or equals to 1. Which one are we going to use? Number 1, number 2, or number 3? Oh, guys, we're using number 3. We write it as the probability of at least, because that is what they say, at least it's greater than or equal to 1. So therefore, it means you're going to add all of them plus 0.15 plus up until you get to 0.25. You have to add all of them because it's the probability that X is at least, which is greater than or equal. Think about when at least, if you don't want to forget what at least means, think about when you read news and there is a bus accident and they are confirming how many people are in hospital or how many people are dead. So we're going to use the hospital one as a scenario. Think about it this way. The news reader will always say, there are at least 3 people in hospital because they are still on the accident scene. Because they don't know exactly, they can be 3 or they can be 4, they can be 5, they can be more than those 3 people that they already stated. So at least will mean more than or equals to the number that you have stated. So always remember that, né? You will never forget it. So what is the probability that the speech therapist will consult with at least 1 child? Is it equals to 1? Oh, and everybody is quiet. So I'm going to be talking to myself. That is correct.
It's equals to 1.
Yes. The probability that the speech therapist will consult with 1 child. How do we find that? The probability, because it's just saying with 1 child. So it's exactly with 1 child, or it is equals to all that, because they don't say, they don't give direction to that. So what is that probability? Option 2 is 0.1, so it is correct. The probability that the speech therapist will consult with no children. What does no children mean? 0, right? So it means the probability of it exactly 0 would be what will be that probability? How do we define an uncertain event? Pardon?
I was saying it will still stay 0.
An uncertain event, the probability will be equals to 0. So it's not always going to be equals to 0, because sometimes there might be some data where a therapist didn't consult with any child on any given day, and they can also count that. But for this example that we have, because the table starts with 1 and 0 is non-existent, so it's uncertain. So that probability is always going to be equals to 0. The probability that the speech therapist will consult with more than 5 children. The probability of what is more than 5? Do we write it with less than, or do we write it with less than or equals to? What is more than? Pardon?
The second one.
The first one.
We write it with the first one. It's more than. More than is that. More than means greater than. The first one, it says it is at least, or it's greater than, or it's no more less, no less than, or something like that. Yes, no less than. That's how we will write it. So what is the probability that it is greater than or greater than 5? Are there any values this side? It's an uncertain event. So what is that probability?
0.
It will be equals to 0. And then the last one, so all these are correct. So the last one, the expected number of children consulting with the therapist on any given day, it's 4. So what they are asking you is calculate the mean. The sum of all values, the sum of the values multiplied by its corresponding probability. So you say 1 multiplied by 0.1 is 0.1 plus 2 multiplied by 0.13 is 0.15 is 0.3, and this is 0.6, and this is 1.2. And 25 will be 0.25 times 5, it's 1.25. So add all of them together and tell me, are they equals to 1 or 4? What is the answer? If you add them,
2.85.
huh?
I've got
I got
3.45.
If you add 0.1 plus 0.30 plus 0.6 plus 1.2 plus 1.25, you get
3.45.
3.45.
Sorry, 3.45.
Please check. You might have missed one value there.
I did, sorry.
Okay, so we left with 2 more minutes. I'm not going to ask you to calculate the standard deviation. You can do that on your own. You can come back to the WhatsApp group to ask us to check if your understanding is correct, and we will gladly be able to assist you there. So this is another one that you can do on your own and try and answer that. I'm just going to go back to the first one that I said you must do. Also this one, remember, you can also do it on your own later on. And if you want us to check if your understanding is correct, you can share your answers on the WhatsApp group and we will gladly give you feedback. It's very important that you practice, especially when it comes to discrete probabilities. These are the basic things that you need to learn. Now, on Monday, we're going to introduce tables. I would appreciate if you can bring your statistical tables to the session. Usually they give it to you in a tutorial format, but if you don't have them as tutorial, they are always accessible from past exam papers. If you can get it from the past exam papers, those who bought the textbook, you can find them on it at the back of the textbook. We're going to use binomial distribution table. So, but the concepts we learned today, or we've learned today, this concept, we are still going to apply them when we deal with other discrete probability questions. So always remember this, what it means, what is more than, what is greater than, what is fewer than, what is below, what is exclusive, what is excessive, what is no less than, what is no more than, what is exactly. You need to know the word phrases and you need to know the symbol and what do they mean. Okay. On that note, for those who
Listen.
don't know, yes?
Sorry, I was saying, can I please have question 4?
Question 4. Okay.
Yeah, exercise 4. Thank you.
So also you can take a picture of this one. Okay, so it's child time. For those who are joining us for the first time in this session, I am Elizabeth. I'm from Pambili Analytics, where we try to bridge the gap on data literacy and analytical skills. We offer a range of services, not just only tutorials, but we do consulting and we offer also skills development training, especially in numeracy, data literacy, research, and statistics. We are still running a special of 150 session, one-on-one session until the end of this month. You can book your sessions via Calendly. And if you are interested in data analytics, you can take one of our self-led online training. to gain access to the recordings, especially free recordings or massive of content that exists, you can go to our YouTube channel. There are recordings dating back to 3 years from now, prior to today. You can subscribe, you can share our channel with the rest of your fellow students. If you want to gain access to the recordings like today's session, those recordings are only accessible to members. So you need to sign in and sign up as a member. We've got 5 categories of membership. We've got the lowest, and then we have these ones. If you want to gain access to the recordings and the notes, you need to join as a loyalist, an appreciator, or a promoter. The other 2, the cheerleader and the supporter, don't give you much of access. But sometimes you might get, for those other recordings that I just share with the members, you might also get. But I must emphasize the point that for you to gain access to the notes and the recording of the sessions, you need to join as one of the following recording. And on that note, I still want to appreciate the 2 ladies, or I'm going to assume that there are 2 ladies who are our loyalists and keep supporting our channel and keep sharing our channel. Let everyone benefit from the kind of support that we are also giving to you. On that note, if you need any assistance or you want to get hold of us, you can contact us via WhatsApp or via email. Those are our contact details. Other than that, enjoy the rest of your weekend. Bye.
Lizzie, I've got a
Yes.
question.
Mm-hmm.
I just want to find out the one-on-one classes, the 150 ends on end of May.
Mm-hmm.
So that one-on-one classes, is it just you're going to do it end of May, or can we pay it and then we do it like when you need it or whatsoever, and you book it and you pay it?
You book it and you pay it. You will
Yes.
you will get my availability times. You can book any of the available time that you want to do your sessions. It's up to you. You can book one session, you can book as many as you want, you can book the whole month, it's up to you. So I will share on WhatsApp the one-on-one Calendly meeting link so that anyone who wants to book a session can look at the availability of the sessions. And I think the times are almost coming to an end for May. Most people have already booked most of the sessions, so you must just check if there are any availability in May that you want to use.
Okay.
Yeah. But yeah, I will share the link.
But
I will also share it on YouTube for those who are not on WhatsApp.
okay, but you can book it and you can use it like on a later stage, like say the availabilities in June, July, or August.
No, you will use it for that month. So if in June
Okay.
we're working with new prices, so you
Okay.
can,
All right.
yeah.
Okay,
Unless
thank you
if
so
you
much.
unless if you book now, yes, you can. If you book now for the dates, because you book in now, it regardless. You book in now for the sessions you want to take, whether you book now and attend them later, but you have this chance of booking with a lower rate this month.
Yeah.
Yeah.
Okay. Yes, that is what I want to know. So I can book at this lower rate, but I can use it. I can book for maybe July or August.
Yes.
Okay.
Yes.
Thank you. Thank you
No
so much.
worries. Thank you.
Thank you,
And
Lizzie.
and have a lovely, lovely, lovely weekend. See you on Monday.
Thanks, Lizzie.
Thank you
Bye.
so much.